baker and influencer, and I am here with ECD now to talk a little bit about thermal profiling. So I'm here with Mark Waterman, and first of all, can you just tell people where to find you here in the exhibit hall?
We're at booth 5723.
All right, so ECD has a lot of technology to help bakers optimize their baking processes, and one of those is thermal profiling. So can you tell us a little bit about thermal profiling and why it's so important?
Well, thermal profiling is just the act of taking temperature measurements while we measure a heating process, whether it be melting solder, baking bread, or cooking cake. So we place sensors in strategic locations, and then we measure the temperature profile or excursion that happens in that baked product as it gets cooked. Why is that important? It is a quantitative measure for a process. So if you want repeatability, you can scale to add extra ovens and repeat the same process. It also can be used to tailor your baking process to get higher yields or higher quality, higher shelf life, reduced reliance on preservatives. There's a whole variety of advantages to being able to measure and repeat a process.
Yeah, that makes sense. Now, I know your flagship product is the mold thermal profiler. Used it a bit in our laboratory. It's gone through several iterations over the years, though. Can you tell us a little bit about how the mold thermal profiler works and why it kind of becomes a baker's best friend?
Well, it is the data recorder. We make different types of sensor platforms based on the product that you're measuring to get a strategic position in the product. In baking, the materials transform during the baking process. They get larger, harder, and change shape. So we need different types of sensor platforms to maintain where that sensor position is in the baked good. So we make the sensors that are application specific, and then they all plug into our data logger. Now the data logger has to go through with the product in this baking process. So we wrap a barrier around it to protect it from the heat, which means that it has to be fairly small. The smaller the data logger, the more insulation we can wrap around it, and the more processes we can survive. Our workhorse is a 6-channel profiler. It has fairly limited feedback loops. We have some LEDs that tell you if you're connected or not when we power this on. Green means that you have a good thermocouple. Red would mean it was broken or open. And if the LED was off, it would mean that that channel was turned off. But fairly limited feedback. We can see when we're recording, and when we're done, we would be tethered to a computer. We would download the data and do all of our analysis on the computer with our analytical software.
Yeah, and it's a fairly robust piece of equipment. I mean, I've sent it down a commercial cracker tunnel oven, 2.5 minutes, very high temperatures, and I mean, it really does a stunning job. So I know here at IBIE, you're kind of giving a sneak preview of your latest iteration. I believe it's the EV6.
Correct.
And so do you want to tell us a little bit about what's changing and some of the new software features that you're kind of putting in there as well?
Well, we talked a little bit about this limited feedback loop we get from the instrument. So the EV6 has an interactive touch display, so we'll be able to get actionable data right from the profiler itself. We won't be tethered to the PC or the PC analytics software to configure the mole or to get initial data from it. So we think that that'll make it not only easier to use, but alleviate a lot of headaches. We deal with IT departments and Windows updates and all kinds of struggles in software. So if we can put it right on the device, and we think it makes the science a little more approachable. We've gone a long ways to simplify our analytics software to make the measures nameable. So where we may be perfectly comfortable as an engineer saying a percentage of process or time above a temperature, bakers may want to know yeast kill or gelatinization, something that they can relate to. So now we let them name the calculation that they want to make it a little more intuitive and approachable.
That sounds great. Well, I think certainly there's a lot of interest in our end, in our laboratory, in seeing this newest iteration. And like you mentioned, there are a lot of different probes depending on the product. So I would highly encourage all of you to come out and visit Mark and his team at booth 5723 and check out what ECD has to offer.